Hello, and welcome back to another episode of the Bytes and Volts Dialogues. The Bytes and Volts Dialogues is a podcast that's brought to you by Logical Titans. At Logical Titans, we set the gold standard in technology services, solutions, and training. Today, I would like to discuss a fantastic topic, and the title of the topic is How to Fix a Computer That is Overheating and Shutting Down. So now, what I would like to present or bring here today is the steps required and the steps that's needed to diagnose overheating issues and shutting down issues. Also, I would like to introduce the main causes and the theoretical and technical causes of this problem. So, do you actually know what happens when a computer overheats? I'll tell you. When a computer overheats, it means that the internal temperature of the computer's components, such as the CPU, the graphics card, and hard drive, has risen to an unsafe level. This can happen when the computer is working too hard or when the cooling systems, such as the fans or heat sinks even, is not functioning properly. When a computer reaches a certain temperature threshold, it would automatically shut down to prevent damage to the components. This can be a serious issue because it can lead to data loss and even hardware failure. Fixing the problem of computer overheating and shutting down is very important to prevent both hardware damage and data loss. If a computer constantly overheats and shuts down, the components inside may be damaged over time. This can lead to expensive hardware repairs or even the need to replace the entire device or the entire computer. Additionally, if the computer shuts down abruptly, there is a risk of data loss if any unsafe work was in progress. In some cases, overheating can also cause data corruption or damage to the hard drive, which can result in the permanent data loss. This is particularly dangerous if you haven't backed up your important files and documents. Dangerous might be a dramatic word to use, but you get the idea. By fixing the problem of computer overheating and shutting down, you can protect both your hardware and your data. This may involve cleaning the computer, improving the airflow, replacing malfunctioning components, or reducing the workload on the computer. Now, there are several causes of overheating, and I would like to highlight a few of them. The very first one is overheating due to dust buildup in fans and vents. And as I have stated before, cleaning the fans and vents is an important step in preventing dust buildup and overheating in a computer. Over time, dust and debris can accumulate inside the computer chassis, clogging the fans and vents and restricting airflow. This can cause the internal components of the computer to heat up and potentially overheat, which can lead to damage and data loss. Regular cleaning of the fans and vents help to prevent this buildup and ensure that the cooling system is working effectively, which can in turn prolong the life of the computer and reduce the risk of hardware failure. Regular cleaning of the fans and vents should be part of your computer maintenance routine. The frequency of cleaning will depend on how dusty the environment is, how often the computer is used, and the type of cooling system in the computer. In general, it is recommended to clean the fans and vents every 6 to 12 months or more frequently if necessary. So now, in order to achieve a clean chassis, you need setting tools. So the tools that you need for cleaning the fans and vents of a computer are relatively simple and easy to obtain. They're rather inexpensive. The first one that you would need is a compressed air can. A compressed air can is a very effective tool for cleaning the fans and vents of a computer. It is a canister filled with compressed air that is designed to blow away dust and debris from hard to reach areas, such as the fans and vents inside of a computer. Using compressed air is a simple process, and here's how you use it. Prior to cleaning a computer's fans and vents, it's important to power off the computer and disconnect it from the power source. Next, open the computer case and locate the fans and vents. When cleaning, hold the compressed air can upright and at a safe distance from the computer's components. using brief bursts of air to eliminate dust and debris, it is essential to avoid continuous spraying as it can lead to compressed air freezing and damaging the components. Continue to use the compressed air until all debris has been cleared, and then use a microfiber cloth to wipe off any remaining particles. Finally, close the computer case and reconnect it to the power source. Microfiber cloth. A microfiber cloth is a type of cleaning cloth that is made of a blend of polyester and nylon fibers. These fibers are very fine and have a static charge, which makes them excellent at capturing and holding onto dust and debris. Microfiber cloths are a gentle and effective tool for cleaning dust buildup on fans and vents because they do not scratch or damage the surface of the components. When using a microfiber cloth to clean dust buildup on fans and vents, it's important to first turn off and unplug the device. Gently wipe the surface of the components such as the blades of a fan or the exterior of the computer case using the microfiber cloth. The static charge in the fibers will attract and hold onto the dust and debris, allowing you to wipe it away without leaving any residue or scratches. Microfiber cloths can also be used in combination with compressed air to clean hard-to-reach areas, such as the insides of a fan and vents, just as we have described in the earlier point. Vacuum cleaner. A vacuum cleaner with a small nozzle attachment can also be used to suck away dust and debris from the fans and vents. A vacuum cleaner can be an effective tool for cleaning dust buildup on fans and vents. When using a vacuum cleaner for cleaning electronic devices, it is important to use a vacuum cleaner with a soft bristled attachment, as this will help prevent any damage to the components. Here are the steps to use a vacuum cleaner to clean dust buildup on fans and vents. To clean a computer safely, it's always recommended to start by turning it off, and that is why I make a case to always remind you to do that. Next, open the computer case and remove any visible large pieces of dust or debris from components such as fans and vents using soft bristle brush. For any remaining dust or debris, a vacuum cleaner with a soft bristle attachment set on low or medium suction can be used to prevent damage to the computer components. When cleaning the exterior of the computer case or keyboard, a soft bristle attachment can be used as well. Finally, a can of compressed air can be used to remove any residual dust or debris from hard-to-reach area. Soft bristle brush. A soft bristle brush is a tool used to clean dust buildup on fan, blades, and vents. It is made up of soft bristles, just as the name implies, that are gentle enough not to cause any damage to the delicate electronic components. Using a soft bristle brush is an effective way to remove dust buildup on fans and vents. These bristles are soft enough to get into tight spaces and loosen the dust without scratching or damaging the surfaces of the components. Great. Now that we've talked about the importance of cleaning fans and vents, let's talk about something else that could also cause overheating, and that is malfunctioning or damaged fans. Here are some signs that you could use to diagnose if your fan is going out or getting bad. The first is loud or unusual noise. If you notice that your computer fan is making a loud or unusual noise, it could be a sign that the fan is malfunctioning or damaged. This could be due to a worn out bearing or an obstruction in the fan blades. When a computer is overheating or shutting down frequently, it is possible that the fan is damaged or malfunctioning. In such a scenario, the fan may not be spinning fast enough to dissipate the heat produced by the computer's components, leading to overheating. Error messages. Some computers may display error messages related to the fan, such as CPU fan error or system fan error. These messages indicate that the computer is not detecting a functioning fan, or that the fan is not spinning at the required speed. In the case that the fan is not spinning at all, it is possible that the fan is damaged or not functioning properly. Also, another thing that you can check for is a burning smell. On the other hand, if you detect a burning smell coming from your computer, it may suggest that the fan is not working correctly. causing the components to overheat and potentially burn out. Now let's talk about how to replace fans. First, you want to identify the faulty fan. The first step is to identify the faulty fan that needs to be replaced. Common signs of a damaged or malfunctioning fan include loud noises, slow spinning, or overheating. You could quite literally feel the heat. Purchase a replacement fan. Once you have identified the faulty fan, you need to purchase a replacement fan. Make sure to get a fan that's compatible with your computer's make and model. The replacement fan should also be the same size and have the same number of pins as the original fan. Next, turn off the computer. Prior to commencing the replacement process, it is crucial to switch off your computer and disconnect it from the power source. This precautionary measure will reduce the likelihood of any electrical or electronic mishaps. Next, you want to open the computer case. It may involve removing screws, clips, or other fasteners that hold the case in place. Make sure to ground yourself using a static band before handling any components to avoid damaging them with static electricity. Next, you would want to locate the faulty fan. Once you have opened the computer case, you need to locate the faulty fan. It may be located near the CPU, GPU, or other components that generate a great deal of heat. To remove the faulty fan, you may need to unplug it from the power source and unscrew it from the case or heatsink. Make sure to keep track of any screws or other fasteners that you remove. I would advise you to take pictures. Now, you want to install the new fan. You place it in the same location as the old fan and secure it using screws or other fasteners. Make sure the fan is properly aligned and facing the correct direction. Connect the new fan. Plug the new fan into the power source and make sure that it's securely connected. Close the computer case once you have installed the new fan. Don't forget to replace and secure any screws, clips, or fasteners that held the case together in the first place. Now you can turn on the computer and check to see if the new fan is working properly. You should notice a significant reduction in noise and improved cooling performance. Now let us talk about ensuring proper airflow and removing obstructions. Here are some tips for ensuring proper airflow. Keep the computer clean. Dust buildup inside the computer can block airflow, so it's important to regularly clean the fans, vents, and other components using methods that we've talked about earlier in this episode. That is, compressed air cans, soft bristle brush, etc. Position the computer correctly. Place the computer in a well-ventilated area and make sure that there is enough space around it for air to circulate freely. Avoid placing the computer in a cramped, enclosed space such as a tight cabinet of some sort. Be sure to use cable management. Proper cable management can help improve airflow by reducing clutter inside the computer. Use zip ties or Velcro straps to neatly bundle and organize cables. Consider additional cooling solutions. If your computer is running hot, consider adding additional cooling solutions such as a liquid cooling, larger fans, or even a more powerful CPU cooler. And be sure to always monitor temperatures. Use software tools to monitor the temperatures of your computer's components and make sure that they are within safe operating ranges. If temperatures are consistently high, take action to improve airflow or upgrade the cooling system. Keep components cool. If you are performing intensive tasks such as gaming or video editing, make sure to keep your computer components cool by using a cooling pad, increasing fan speed, or adjusting the power settings. Awesome. So now let's talk about upgrading the cooling system or thermal paste. I would like to start by talking about the types of cooling systems available. First is the air cooling. Air cooling is a widely used method for cooling computers, which entails using one or more fans to circulate air around the computer parts for heat dissipation These fans are usually installed on the computer case or on specific components like the CPU or graphics card to absorb the heat produced by the parts. Heat sinks made of metal plates with fins that increase the surface area for better heat dissipation are used. We also have liquid cooling. Liquid cooling, also known as water cooling, is a type of cooling system that is used to dissipate heat generated by computer components. It is a popular cooling solution for high-end computer systems that require more cooling capacity than traditional air cooling can provide. In a liquid cooling system, a coolant liquid is circulated through tubes that are attached to the components that generate the most heat, such as the CPU and GPU. The liquid absorbs the heat from the components and then flows to a radiator, which is usually mounted on the top or back of the computer case. The radiator is designed to dissipate the heat from the liquid, and it is typically equipped with fans to improve the airflow. We also have passive cooling. Passive cooling is a type of cooling system available in the computer that uses heat sinks to transfer heat away from the components without the use of fans or pumps. Heat sinks are usually made of metal, such as aluminium or copper, and have a large surface area to dissipate heat. They work by conducting heat away from the components and into the air, where it is carried away by natural convection. Passive cooling systems are generally quieter and more energy efficient than active cooling systems that use fans or pumps, since they don't require any additional power to operate. We also have phase change cooling. Phase change cooling is a sophisticated method of cooling using specialized or high-end computers. It operates by utilizing a compressor and refrigerant to cool down the computer's components. The cooling process begins with the compressor compressing the refrigerant gas, elevating its temperature and pressure. Then, the hot gas is channeled through a condenser where it dissipates heat and subsequently transforms into a liquid state. The liquid then passes through an expansion valve, causing it to expand swiftly and cool down. Finally, the cooled liquid flows through an evaporator, which absorbs heat from the computer's component and changes the liquid back into a gas. The cooling cycle continues in this manner. We also have thermoelectric cooling. Thermoelectric cooling is a type of cooling system that is based on the Peltier effect, which is a phenomenon in which heat is absorbed or released when an electric current flows across a junction between two materials. In a thermoelectric cooling system, a Peltier device is used to transfer heat away from the components. The Peltier device is a small flat module that consists of two ceramic plates with a layer of semiconductor material between them. When an electric current is applied, heat is absorbed at one plate and released at the other, creating a temperature difference between the two plates. By placing the hot plate in contact with the components that need to be cooled, and the cold plate in contact with a heat sink or a fan, the Peltier device can transfer heat away from the component and dissipate it into the surrounding environment. Now let us talk about how to apply thermal paste. First, you want to prepare the surface. Before applying the thermal paste, make sure the surface of the CPU and heatsink is clean and free of all thermal paste, dust or debris. Use a soft cloth or alcohol wipes to clean the surface if necessary. Next, apply the thermal paste. To apply the thermal paste, start by placing a small amount at the center of the CPU, which is typically about the size of a pea. Be careful not to use too much paste as it may impede the effectiveness of the thermal transfer. You can use a plastic spreader or small plastic bag to spread the paste evenly over the CPU surface. Next, attach the heatsink. After applying the thermal paste, align the heatsink with the retention mechanism and gently press down to ensure that it is properly seated. Next, tighten the screws. If your heatsink uses screws to attach to the retention mechanism, tighten them in a diagonal pattern to ensure even pressure on the CPU. Be careful not to over-tighten the screws, as this can damage the CPU or heatsink. Then, you want to check the temperature. Once the thermal paste is applied to the heatsink and it is all attached, turn on the computer and check the CPU temperature using any monitoring software. If the temperature is still too high, you may need to adjust the amount of thermal paste or reseat the heatsink to ensure proper contact with the CPU. Now, let's talk about cooling pads, using the cooling pads for laptops especially. There are multiple types of cooling pads available. There's the passive cooling pad. Passive cooling pads are a type of laptop cooling pad that work without any fans or power source. They are designed to provide additional space between the laptop and the surface it sits on, which allows to increase airflow around the laptop and allows it to dissipate heat more effectively. Passive cooling pads are typically made of materials such as metal, plastic, or rubber, and are available in a variety of sizes and shapes to accommodate different laptop sizes. Passive cooling pads can help to reduce the temperature of a laptop by a few degrees, which can be helpful in preventing overheating and prolonging the lifespan of the laptop. They are also lightweight and portable, making them a convenient option for people who use their laptops on the go. We also have active cooling pads. Active cooling pads are designed to enhance the cooling performance of a laptop by increasing the airflow around it using one or more fans. This type of cooling pads are typically powered via USB, and some models can come with adjustable fan speed settings. Active cooling pads can come in a variety of shapes and sizes and may feature a single large fan or multiple smaller fans arranged in different configurations. The fans draw cool air from the surrounding environment and direct it towards the underside of the laptop, helping to dissipate heat and reduce the overall temperature of the laptop. Hybrid cooling pads. Hybrid cooling pads are a type of laptop cooling pad that combines both passive and active cooling mechanisms to enhance the cooling performance. These cooling pads typically feature a raised design to promote airflow around the laptop, as well as one or more fans to increase airflow even further. The fans can be adjusted to different speeds to help regulate the temperature of the laptop. The passive cooling mechanism of hybrid cooling pads come from the raised design, which creates a gap between the laptop and the surface it is sitting on. This gap allows more air to circulate around the laptop, which helps to dissipate the heat. Liquid cooling pads. Liquid cooling pads, also known as liquid cooling systems, are a type of laptop cooling solution that use a liquid coolant to transfer heat away from the laptop's components. They typically consist of a pump, a reservoir, tubes, and a radiator. The coolant is circulated through the tubes to the necessary component, where it absorbs heat before returning to the reservoir. The heated coolant is then passed through the radiator, which dissipates the heat into the air before the cooled coolant is pumped back to the laptop's components. Liquid cooling pads are highly effective at dissipating heat and can provide more efficient cooling than other types of cooling pads, making them ideal for gamers or users who run intensive applications on their laptops. Here are some tips for managing programs and applications that may in turn reduce overheating. First, close unnecessary programs. Running too many programs at once can put a strain on your computer's resources and lead to overheating. Close any programs or applications that you're not using to reduce the workload on your computer. Monitor your computer's performance. Keep an eye on your computer's CPU and memory usage to ensure that it is not working too hard. You can use built-in tools like Task Manager that's for Windows, or activity monitor on Macintosh to monitor your computer's performance. Adjust settings for resource-intensive programs. Some programs, such as video editing software or games, are more resource-intensive than others. Adjust the settings of these programs to reduce the strain on your computer's hardware. Update your programs. Keeping your programs up to date can ensure that they are running efficiently and not causing unnecessary strain on your computer's hardware. Finally, use an external cooling solution if needed. If you regularly run resource-intensive programs or applications, consider using an external cooling solution such as a cooling pad or a desktop fan to help manage the heat generated by your computer. This final section is dedicated to the power users out there. The power users who usually overclock the CPU or GPU beyond safe limits. There are certain risks that come with overclocking. Overclocking involves pushing the clock speed of a computer's processor, graphics card, or other components beyond the manufacturer's recommended limits in order to enhance performance. This technique aims to maximize the hardware's capabilities without requiring the purchase of a more powerful component. Nonetheless, there are several risks associated with overclocking. One of the major risks is overheating, which can occur when increasing the clock speed, resulting in higher power consumption and heat production. Overheating can lead to system instability, crashes, and permanent hardware damage. Another risk is a reduced lifespan of the hardware, as overclocking can cause increased wear and tear, potentially leading to permanent failure. Furthermore, since overclocking is viewed as a form of modification, it may void the hardware's warranty. Finally, it is essential to note that overclocking requires technical expertise and can be challenging. Improper overclocking can result in negative outcome, including hardware damage and, in some cases, breaking the hardware. Awesome. So we are approaching the end of today's episode, and I would like to wrap up with a summary of today's topic. Overheating is a common problem that can cause serious damage to a computer if not addressed promptly. Dust buildup on fans and vents, malfunctioning or damaged fans, blocked airflow, inadequate cooling system or thermal paste, high ambient temperature, and overclocking are some of the common causes of overheating. Signs of overheating include system shutdowns or reboots, performance issues, unusual noise, and elevated temperatures. To prevent overheating, it is recommended to clean fans and vents regularly, replace damaged fans, ensure proper airflow, upgrade the cooling system or thermal paste, and avoid overclocking or manage it with caution. In addition, reducing ambient temperature through air conditioning or ventilation and managing programs and applications to reduce CPU usage can also help prevent overheating. It is important to address overheating promptly to avoid potential damage to the computer's hardware components. Thank you for joining me once again to listen to discuss technology topics. I would like to hear what you think about the podcast or things that you would like to be discussed. Thank you very much, and I hope to see you next week. Ciao.